All right, so guys, on the homework for speed and velocity, we have all the variables and the units for the most part, which they should normally show up in. Besides a couple problems, they may have hour and or kilometer as a unit. All right, and then the triangles here show the equations. So you don't maybe see the equations written. If you're not sure, you can always go click on this video. Again, you should have watched this yesterday to do the notes, and you can get the equations from there. But I'm going to show you how to use the magic triangles here. How this works is you cover up the letter that you're looking for, and then it tells you what to do. So if I cover up S, it is D divided by T. So I wrote it out. Bam. If I ask you to solve for the distance, if they're next to each other, you're going to multiply. So distance is speed times time. Oh, yeah. Straight fire. Then we have distance. Or sorry, we were looking for time. So we're going to take the distance traveled divided by our speed. D over S. And it's the same essentially for the other side. Solve for velocity. All right. Displacement over time. Delta X over T. If you're looking for displacement, all right, your average velocity times time. And then if you're looking for the time, if you cover up T, delta X divided by V. All right, so that is how you work them triangles out. Bam, bam. Heck yeah. So going into our homework assignment. Usually to 2 decimals, yes. Rounded 2 decimals would be great. I mean, if it comes out nice, like the one we had in the first assignment today, the 0.375, yeah, leave it.
What if it's
8 repeating?
Yes.
Then you can chop it off at 8.89. So here we got a distance of 100 kilometers and 2 hours. What is the average speed? So speed, cover up S in the triangle. What does that equal? D divided by T. So S is our question mark. S equals distance divided by time. So we need distance. Distance is equal to what? 100 kilometers. How long are we moving for in this? 2 hours. So in the equation, speed is equal to distance divided by time. Let's space this out just a second. The distance was 100. The time was 2. And then that's going to give us 50 as the magnitude, but what about our unit? What was the distance unit in this problem? Kilometers. And then what was the time unit? Hour. So we can just write it as 50 kilometers per hour. All right, you guys will be able to, definitely should be able to do number 2. You should be able, all right, so let's look at 3 for a second. They're asking us to solve for the distance. So the distance is equal to what? If I had to solve for distance in the triangle, if I cover that up, what am I doing? Good, S times T or speed times time. We're given speed, we're given time. So distance is equal to speed times time. So speed was 5, time was 0.5, and that is what? 2.5 is the magnitude. What about my unit? Good, kilometers, because the time unit will cancel out. The time units here will cancel out. So you're going to be left with whatever the distance unit is in your speed or velocity when you have to solve for either distance or displacement. So we're going to have just kilometers. Bam, 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 bam. In number 4, you're asked to solve for time. You're asked to solve for time. So you posted a speed limit on the road, all right? The speed limit is 45 miles per hour, which is roughly 20 meters per second. And you live, all right, 8,000 meters from school. How long would it take you to get there if there is no traffic? So we're looking for time. So the equation for T in the speed triangle is what? If it's covering up T, I'm doing what divided by what? Very good. All right, so t equals d divided by s, distance divided by the speed. Do we have each of them? Heck yeah, we do. The distance here would be 8,000 meters, and we're dividing that by 20 meters per second. So we have 8,000 divided by 20, and that's going to give us an answer of 400 seconds. Why is it going to be seconds there? Because the distance units wind up canceling out, and because obviously time's not measured in meters. All right, we're getting seconds. But they ask here to convert your answer to minutes. How would you do that? Right, so how many seconds are in 1 minute? 60. So if I said, hey, I have 400 seconds, and every 60 seconds is 1 minute, I would do 400 divided by 60. And that's going to equal 6.6 repeating, so we'll call it 6.67 minutes. Cool? Cool. Ooh, 5. All right, well, I'm not going to do all 5 with you, but I'm going to just help you with the sets up. Ladybug walks 10 centimeters forward and then 5 centimeters backwards in 20 seconds. They want to know what the average speed is. So they're looking for S. All right, we've done a problem like that. But what is the total distance here? Good. All right, you weren't fooled at all. Okay, so 15 centimeters. Now your unit for speed is going to be in centimeters per second because that is the distance unit they gave us here. But now I want to look at number 6. It's the same motion, the same kind of trip, but now instead of average speed, they're asking you for average velocity, v. So if I went up to the triangle in v, right, cover that up, I have to do delta x divided by t. So v is going to equal, I'm going to control C that, copy this divided by t. Okay. I like to have all my answers here highlighted in yellow just because it's just makes it pop. It's easier to see. Heck yeah. That would be awesome. I appreciate it if you did. So what about this one? What is a displacement? Displacement delta x. How far you are from where you started?
5.
Yeah, it's going to be 5, right? Because you're going 10 centimeters forward and then 5 backwards. So it'd be like going 10 to the right and then 5 to the left. So you would still be 5 meters from where you started. Okay. And this one is not going to be negative in this case. Now, if they said you walked 5 centimeters forward and then 10 centimeters backward, then you would have a displacement of -5. But we have 5 centimeters as our displacement. So, yeah, buddy. All right, and you know the time, and then you guys can solve about that. Here, you can solve. And then, so number 8. They're telling you, hey, you went east, you went north in 7, and then you did it for this many seconds. Average speed in meters per second. Cool. Well, remember, guys, from the like earlier in the week, are vectors. All right, you can only add them or subtract them if they're in the same or opposite directions. But what happens when we have something in the x direction, like this guy here, this 600? Whoop, excuse you. All right, this 600 is in the x direction, so it's either going left or right. And then you have another vector quantity in the y direction, up or down. So if that's the case, you can't add or subtract them. Remember, we have to use our Pythagorean theorem equation rearranged. So first, you're going to find the resultant by using that equation. And then I wrote it in here for you guys. That is your displacement, delta x. So once you do and get that, you already have t. Then you solve for your velocity. Okay, so you guys are to do the remaining questions. So remember, we didn't finish 5. 6, 7, 8, and 2. All right, but I set you up on a few of them, so you guys should be able to knock those out of the pack. Okay?